Hello everyone, I am Manoj Shankar Jaganade, Assistant Professor, MBA Department, DGICM Nagpur. Today our topic is correlation and regression analysis. So in this we are going to see correlation analysis first. So what is meant by correlation? It is a study of linear relationship between two variables is known as correlation. It is simple term. Then we will see types of correlation. So there are on the basis of direction, on the basis of number of variables, and on the basis of ratio of change of direction. So there are three ways, and on the basis of direction, two correlations are there: positive correlation and negative correlation. On the basis of number of variables, simple correlation, multiple correlation, and partial correlation. And on the basis of ratio of change direction, that is linear correlation and non-linear correlation. So now we are going to see in detail what is meant by positive correlation and negative correlation. So first one is positive correlation. You can see the data given below in the table. Positive correlation means what? Let's consider data from 1, 2, 3, 4, 5, 6. You can see here the sales is increasing, that is 50 to 60, 60 to 70, 70 to 80, 80 to 90 and 90 to 100. In the same way, expenses is also increasing continuously. 11, 15, 19, 23, 27, 31. If you carefully observe, sales is increasing by 10, means 50 to 60, 60 to 70, means there is a constant increase and constantly increasing, and the difference between all the variables is same, means 50 to 60. So the difference between two consecutive data is similar. In the same way, if you see in the expenses, 11 to 15 means difference is 4, 15 to 19 difference is 4, 19 to 23 difference is 4, 23 to 27 difference is 4, means difference is always same in the consecutive data. So in the both sales and expenses we have seen that kind of pattern. So first quantity is increasing with some rate, and also second quantity is also increasing with the same kind of rate. So such kind of correlation between the sales and expenses we can call it as a positive correlation. Okay, means the rate of change of sales is exactly equal to the rate of change of expense. Okay, and sales is also increasing, expense is also increasing, means rate is same and both are increasing, means obviously there is a positive correlation. Okay, then next, negative correlation. Here you can see production in kg and price per kg. The first value is 100 to 200, 200 to 300, 300 to 400, 400 to 500, 500 to 600, 6 to 7, 7 to 800. Okay, but if it is increasing by 100, continuously it is increasing by 100. Okay, in the price table now we can see 10 to 9, 9 to 8, 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3. Means it is decreasing. So it is totally opposite. First row is increasing data and second row is decreasing data. The rate of increase in the first horizontal data and the rate of decrease in the price table. So it is exactly, the rate is exactly equal, but it is in opposite direction. First is increasing, second is decreasing. So that's why we will call it as a negative correlation. Okay. Then linear correlation and non-linear correlation. Linear correlation means what? In linear correlation, the change in the value of one variable has a fixed ratio to the variation of values of other variable. Let's understand by observing a table. Okay, Let's see the table. The mustard in kg is given and oil in kg is given. So now you can see 10, 20, 30, 40, 50, 60, 70, 80. It is increasing. Okay. So it is nothing but the table of 10. Now in the oil, it is also increasing and it is the table of 3. Means you can also say that it is a perfect example of positive correlation because both the quantities are increasing and it is increasing with the same kind of rate. Okay. So if you plot all these things, all the data, then you will get a linear line of any locus connecting all the points. Okay. So that's why it is called as a linear correlation. Now consider non-linear, that is curvilinear correlation. Let's see here in this table, use of fertilizer in kg and production of rice in kg. So just see use of fertilizer 1, 2, 3, 4, 5 means there is a common difference of 1, okay, between two consecutive data. Now production of rice, see 4, 6, 9, 17, 28. The difference between two consecutive data is not fixed here. It is not common. Means it is increasing, but it is not increasing with the same rate. So it is rapidly increasing. So if you plot this data on the graph, you will not get the linear or a locus of a line. Means you will draw a locus joining all the points, you will get a curve. So the linear data is not given here, that's why it is called as a non-linear correlation. Okay. Now let's understand what is simple, partial and multiple correlation. Simple correlation means what? It is in general, when there is a two variable and the relationship between the two variables, then we will call it as a linear and simple correlation. Okay. We will call it as a simple correlation. Generally example is given, relationship between sales and expenses, income and consumption. What is partial correlation then? Let's see the example. Consider the two variables height and weight, which are partially correlated because the effect of third variable age on height and weight. If we are considering height and weight, but age is also a factor which can affect height and weight. Okay. So if we are considering height and weight, then we have to make age as a constant thing. Means we have to consider if we are considering adults, so obviously the age factor will be there. The persons who are more than 18 years of age, they are only considered as a adult. So in such a situation, when there is a possibility of third variable, so on that third variable there may be some dependency on that particular factor. So that in that condition we will say it as a partial correlation. Okay. So let's see, in this condition, if we neglect the effect of age, the relationship between height and weight, then correlation is known as partial correlations. Means we have neglected a factor, then we will call it, that particular correlation will be the partial correlation. Okay. The third one is multiple correlation. Means multiple factors affecting a single variable or one variable. We have given here, we have the example, the relationship of rainfall and temperature on the yield of wheat. Not only rainfall and temperature, the quality of soil, the area of soil, that also affects on the yield of wheat. So there are multiple factors, multiple variable which affect or give effect on single variable. So in such a situation we will call it as a multiple correlation. Okay. Now degree of correlation. Okay. We know very well, if two data is given, one is increasing with a constant rate and other is also increasing with the same kind of constant rate, then there will be the positive correlation and it will be +1. The coefficient of correlation will be +1. And we can see the example. If you see here in the positive correlation, if you calculate the coefficient of correlation, you will get +1, and in the same way it is increasing. In the negative correlation it is increasing and the price is production is increasing and price is decreasing with a constant rate. So if you calculate the coefficient of correlation, you will get -1. So perfect correlation, positive correlation, what is meant by perfect correlation? If it is a positive correlation, then it should be +1. If it is negative correlation, then it should be -1. The second one is absence of correlation. If we are unable to find the relationship between the two variables, then such a kind of we can call it as a absence of correlation. After that, limited degree of correlation. So we can understand it in better way by using that table. So limitation, if it is high, let's see in the positive correlation coefficient, if it is high, then it should be between 0.75 to +1, plus 0.75 to +1, and moderate means 0.25 to 0.75, and if it is low, then it should be between 0 to 0.25. It should be between, not 0, because if it is 0, then it will be the absence of correlation. Now see in the column of negative correlation coefficient. It can be called it as a perfect correlation, but it is negative when the value is -1. When it is between minus 0.75 to -1, then it is limited correlation of high. Means it is limited negative correlation. Limited negative correlation, and degree will be high. And if it is moderate and negative, then it will be minus 0.25 to minus 0.75. The printing mistake is given here. There should be minus 0.25 to minus 0.75, and if it is limited and the degree will be low, negative, then between 0 to minus 0.75, minus 0.25. So in that way we have seen the degree also. Now methods of computing correlation. Methods of computing correlation: scatter diagram, Karl Pearson coefficient of correlation, and Spearman's rank correlation. So we will see the scatter diagram here. Let's see the graph. First one, highly positive correlation. You can see the set of three sets of point is there, and all are linear, and whatever the data is given, the value of x is increasing, the value of y is also increasing. You can see, because data is moving from left to right and it is upward direction. So the value of x is increasing, also the value of y is also increasing. That's why it is called as a positive correlation. But in the B diagram, B graph, if you see, the data is moving on right hand side, means x value is increasing, but it is coming down, means y value is decreasing. So one quantity is increasing and other quantity is decreasing, means there is a negative correlation. And in the C graph, absence of correlation, because we cannot locate or we cannot draw a locus. We cannot join all the points with the same line. So we are not getting a proper locus. So we cannot determine whether the data is increasing or decreasing. So here there is the absence of correlation. Let's see, if the single data is given and if we locate all the data and it is coming under same line, means one single line can locate all the data and it is increasing, the data is increasing. So I have already told you the value of x is increasing, value of y is also increasing, both values are increasing with the same rate, then it will be the perfectly positive correlation. And in the same way, the value of x is increasing but the value of y is decreasing because the data is coming downwards as it moves towards the right. So it is coming downward, so it is perfectly negative correlation. Okay. Now there is an example. Draw a scatter diagram for the following and indicate whether the correlation is positive or negative. So just see here first, 10, 20, 30, 40, 50. It is increasing data, and second one is also increasing data because 20, 40, 60, 80, 100. The rate, the first data is consecutively increasing by 10 and second data is consecutively increasing by 20. So there is a constant rate of increase. Okay, there is a constant rate of increase and both data is increasing. So obviously that example will be of perfectly positive correlation and the correlation value will be +1. Here we can see the solution. I will also tell you how to find the coefficient of correlation. For this we will use Karl Pearson coefficient of correlation. Okay, we have the formula for it, we will see it. Okay, so that is the formula, but I will teach you, I will give you formula, don't refer this. There is an example, we will solve this example in our class. Okay, and you don't have to worry about all these examples, we will solve all these examples in our class. So I have provided you and we will learn very quickly. If it is possible, today itself we will take the class to solve these examples. I hope you got the information given in this video. Thank you very much.